guys, hope all of us are doing fine. Today we're going to look at a topic which is going to be a build-up of particularly what we had discussed earlier on acids and bases. We had looked at different definitions for acids and bases, which basically gave us a clue on how we can identify substances that are going to fall under these two categories. Now, autoionization of water, which is basically our topic of discussion for today, is going to shed light on how we can be able to identify basically an acid or a base, and this is going to lead to a development of a scale basically which we refer to as a pH scale, and this is going to assist us of course in identifying further on how substances can be regarded as insofar as acids and bases are concerned. So I'd like to invite us into the topic. As we discuss this particular topic, of course I'm going to put a link over the description of our first discussion on acid base topic on the link on the description box, so that we can check and try to contrast it with this particular discussion. And that is it for now, guys. I hope that some of us have gone to YouTube and searched Honesty Sciences and Mathematics TV channel and have subscribed so that we can be getting updates on our recent uploads. So that is it for now. Thank you and welcome. So as I've said, we're going to look at this particular discussion on autoionization of water, and this basically is going to shed for us a light on how we can be able to identify substances as either acids or bases. And if we try to look at our previous definitions, we had given a definition of an acid base from the Arrhenius perspective. This is Arrhenius definition of an acid base, and then we talked about the Bronsted and Lowry definition of an acid base, and then next we had looked at the Lewis definition of an acid or a base. From these particular definitions, we had a variation of how these particular individuals looked at substances as either acids or bases, and basically across we found out that there was a heavy of course emphasis on the proton, either as an acceptor or proton donor, and then there was a comparison of that one with the hydroxide ion. So basically, if you try to look at autoionization of water, water basically is a substance that is made up of the OH group that has been combined with this particular proton to form water. So in this case, we're going to see that in some specific, under some specific conditions, it is basically a reverse. We're going to have a reverse reaction, which is either going to form water or these particular ions, especially when we're trying to talk about the concept of ionization. So therefore, if we try to talk about autoionization, then we're going to infuse the condition of equilibrium, whereby this equilibrium is going to assist us to try and figure out whether a substance is either acidic or basic. But basically, this is going to assist us in trying to develop the pH scale, which is going to be very essential for us in understanding this topic. So if we try to look at what we had actually looked into, which is basically going to lead us into autoionization of water, we had said that there are some substances which we can regard as amphoteric. And these are substances which are displaying both acidic and basic properties. Therefore, we can be able to refer to them as amphoteric substances. Now, one of the examples of amphoteric substances is water, which is basically our topic of discussion for today. And we're going to see that water is depicted as an amphoteric substance, especially when we're going to consider the point of autoionization equilibrium. And we said that for the forward and reverse reactions, there's a point whereby the forward reaction is equivalent to the reverse reaction. And this point, we say that we'll have attained equilibrium. Now, suppose I give an illustration for this water molecules, and just give an example of this, whether it's appearing as a standard stoichiometric equation, but I'm just going to use this one for illustration purposes. So we're going to have those two water molecules having a forward and reverse arrows as such. So these ones are going to form hydronium ions plus, of course, that particular OH group at that point. So this dissociation is going to form ions, and this is, of course, we can just write two water molecules, but for the case of this reaction, I'm just going to give it as such. So we have this one as aqueous solutions for those, or aqueous state for those specific ions. So as we have said, we are going to have this specific point a state of equilibrium, and we're going to have what we call an equilibrium constant that is going to be attained. Equilibrium constant. We're going to learn about this concept of equilibrium constant, especially in some topics in physical chemistry, just like this one, perhaps in an exclusive video and in deeper details. So this equilibrium constant is given an initial of Kc, and it's given as Kc is equivalent to the concentration of the hydrogen ions and the concentration of the OH ions as such. So this is a product of the concentration of these two specific ions, and the equilibrium constant is going to vary depending on the type of reactions. Now, we already talked about in our chemical kinetics, we have mentioned the concept of exothermic or thermochemistry. We had mentioned the concept of exothermic and endothermic reactions, and this basically was in reference to the temperatures that was obtained during or after the reaction, or the changes in temperature that were realized during the chemical reaction. So for that case, this equilibrium constant is going to change with the changes in temperature depending on the nature of the reaction, whether it's exothermic or endothermic. And of course, most importantly is that this constant value for water is going to be obtained at a temperature of 25 degrees Celsius. And in most of our reactions, they are going to be accompanied with some conditions. Of course, we have mentioned on the concept of a standard temperature and pressure. Now, for this particular constant for water, it's going to be achieved at that particular temperature, and this is going to be referred to as ion product of water, which is going to be denoted as Kw. So I'd like us to take note of these particular conditions that we're trying to mention. Now, I've said that there's an equilibrium constant that is denoted as Kc, and this equilibrium can be achieved from this specific equation that I've given for the product of the concentration of the hydrogen ions and the hydroxide ions. And number two, I've said that this particular constant changes with changes in temperature depending on whether the reaction is exothermic or endothermic, and we have given it a condition that for water it's being achieved at 25 degrees centigrade, and this basically the value that is achieved at 25 degrees centigrade is referred to as the ion product of water that is denoted as Kw. So from this particular point, then therefore we're going to look at specific illustrations for the concept of a Kw at 25 degrees centigrade, and this is going to have a particular value that is going to be obtained for this particular case. So if I try to give it in an essence the value for ion product of water, and therefore this is going to give me the concentration of the OH group and the concentration of the H positive, and then this value is going to be 1.0 times 10 negative 14, and this value is going to be the mole square decimeter, and that is to negative 6, and then this is going to be achieved at 25 degrees Celsius. So this is going to refer to the ion product of water. Now, given that in this reaction the mole ratio of course are given for the OH group, and the H plus is 1:1 at equilibrium, therefore we are going to consider the fact that this particular ions for the mole ratio of 1:1 therefore are going to share this value, and we can just have that one given as either represented by the H positive, which is a square, or which is basically equivalent to OH negative as the square of that. So basically this implies that we can equate the OH group to the H group, since the mole ratios for the formation of this particular ions at equilibrium is going to be 1 to 1. So therefore we can either consider either AH group as H positive, which has been squared in order to attain this value. Therefore, it will be logical for us to have a conclusion that basically for the H positive, and therefore this one can be equivalent to a value which is derived from this, which is 0.10 and -7, which basically is a root of that particular value. So therefore, this is going to be in terms of mole squared, this meter 3 given so this is basically going to be, yeah, for pure water, it's a positive square of this. So this is going to be pure water at this particular condition for the hydrogen ions respectively. So therefore, from this particular case, this is going to be give us a clue on how we are going to refer to this specific scale, whereby we're going to see that a solution whose hydrogen ions concentration is greater than that of pure water, therefore, is going to be referred to as an acid, whereas a solution whose concentration is of OH is smaller than of pure water is going to be referred to as basic. Now, this is trying to give us a standard condition that we're going to use in comparing whether substance is either basic or acidic, and I talked about the condition of a standard temperature and pressure. So if you try to look at this particular argument, which is ion, of course, that we mentioned of ion product of water Kw. This is considering two ions at equilibrium that have got a value of this particular figure in at that particular temperature, and therefore we say that it is the mole ratios is the same. Then therefore, the concentration of a specific ion for OH or H group, then therefore can be a square of this value. A root of this value, which we have denoted at this specific temperature. Now, therefore, this is going to be considered as a standard whereby we are going to compare this one for solutions with a higher or lower concentration for us to define them as either acidic or basic. But whereby a solution that is going to consist of a concentration that is similar to this particular concentration of the OH group at 25 degrees centigrade, then it's going to be considered to be neutral. So in any case, if we try to look at a few examples of this particular argument, then we can be able to conclude that if we have the concentration of ions which are equivalent or maybe greater than 1.0 times 10 negative 7 for the OH group, and that is going to be considered as acidic. And if we have this is going to give a comparison between the values at this specific point, and if we have the concentration of that specific ion, that is for OH, which is smaller than 1.0 times 10 negative 7, but of course for the OH group, which is greater than that particular value, then we're going to consider this particular square bracket for this case. Then we're going to consider this particular substance to be basic. So we're just trying to use the equality and inequality signs in this particular case to just give a summary of what we have discussed. But if we have a concentration of H positive, which is equivalent at 1.0 times 10 negative 7, which basically is equivalent to the OH group. This is depicting the mole ratio of 1 to 1 that we had said in these three conditions. Therefore, it's going to be referred to as a neutral substance. So basically, this is going to open for us a window of discussing the pH and other P scales, which are going to give substances as either basic or acidic, as we had looked earlier. So the pH scale is one of the applications of this autoinization of water that we have discussed, and this is also going to be handy whenever we're trying to talk about concentration and other topics which are related. So catch us in our next videos. We're going to look at the pH and the other pH scales, which is going to assist us, of course, pin down substances, whether they fall under the category of acid, bases, or neutral substances. So that is it for now, guys. Bye. God bless you.